theta, and we did find horizontal on Friday, so we're going to just find vertical. That sound right to everyone? So what am I going to do to find the vertical points of vertical tangents? Yeah, I need to find dx dt because that's n dy dx. Dx dt is the denominator, and the denominator being 0 would cause points of vertical tangents. So I need to find first x, which is r cosine theta. Any questions so far? Dx dt would then be, which you could distribute and do it that way, or you could do product, it doesn't matter. Left, d right, plus right, left, positive 2 sine theta. Let's see. Is that solvable? But I can't. Plus 4 sine theta cosine theta. Everyone agree? Factor out a sine of theta. Everyone agree? If I were going to solve this by hand, I would have to factor out a sine of theta. 2 sine of theta if you wish. Not a requirement on the 2, but oops. So negative 1 plus 2 cosine theta. Am I going too fast on this solving, or okay? Good. So each piece equal to 0. Sine theta equals 0, and 2 cosine theta equals 1. Add the 1 over. Cosine theta is a half. Sine theta is 0. Sine is 0. Well, there wasn't an interval, right? And then what did I decide I was going to use as an interval? 0 to 2 pi, because x and y are going to be the same. After 2 pi, I'm going to start with, because I want the points. I don't want theta. I want the points, which would be x and y values. Theta would be 0 and pi. And you could put 2 pi, but again, you're going to get the same sine and cosine value at that 2 pi as you are at 0. So you would start to get repetitive answers. So 0 and pi is enough. And yes, it's 6 pi over 3 is all the way. You're right. Okay, any questions about that? And I want the points. What was x was 2 minus 2 cosine theta times cosine theta. Y was that sine theta, right? And so sine of, or the 0 and the pi, y is 0 on both of those. Do you agree? Times sine. Makes sense. Okay. So the 2 points from the 0 and the pi are have y values of 0. The x value on the first one, on 0, cosine of 0 is 1. So still 0. And then cosine of pi is negative 1, so that would be 4 times 1. 4. Cosine of pi would be 4. Well, when you plug in, right? It is. Okay, plug in pi over 3. I know that cosine of pi over 3 is a half. So 2 minus 1, which is 1 times a half. So I get 1 half for x.
Shouldn't that be negative for us?
Possibly.
Times cosine theta 70 cosine.
Yes.
That'd be cosine.
And 1 half again for both of those x values. Check that, make sure I'm right. Since cosine equals a half, it's going to be the same for both of those. Y values I'll actually have to check. Sine of pi over 3 is positive radical 3 over 2. Sine of 5 pi over 3 is negative radical 3 over 2. So they'll be the same except for a negative sign. We'll keep that in mind. So pi over 3 is just radical 3 over 2. And just negative radical 3 over 2. Is that right? Check my work. I'll wait while y'all check. Please do. I need to move it up a little bit.
I have a question. What are you plugging in? Are you plugging in the Are you plugging the things that we found?
Yes. Well, these are just vertical. All 4 of these are vertical tangents. Yeah, the horizontal tangents we found yesterday, it might not have actually found the planes. So now you know how to actually find the planes. I think we might have stopped there because I was trying to get to at least touch on area yesterday.
We plug it into both x and y.
Yes. Now I took some shortcuts. I knew that sine of both these things was 0 from that. And so immediately I went to this one and said, well, that's 0. And so that's how I got those 2 zeros pretty quickly. Then I actually had to go back and plug those in to the x.
So you can do the same thing kind of for the right hand cosine.
I knew that cosine of theta for both of these was a half. So that's why I did the x so quick, because I knew cosine was a half. It slowed me down a little on this one because I had to think about sine. Okay. So back to area. We talked about this yesterday. Did we finish this one yesterday, or do we need to finish it? Right.
We got to the integral, but we never did the integral.
We set up the integral to stop there, and let's it was 1 half the integral from 0 to 2 pi of 2 plus 2 cosine theta squared d theta. So yeah. By hand, this is a very nasty integral. I'm going to show you how it's done by hand, mainly for those of you going on in calculus. I don't think it's an integral you would ever have to do by hand in AP calculus. This is mainly just for those of you going to later calculus.
So we won't be in.
Not by hand. Not by hand. Now, could I make you find it? Yes, because you can type that right there in your calculator. Or if it's not a calculator, just set it up and set it back. Just for fun. To do this by hand, you would have to FOIL that square out. Which you would get 4 plus 4 cosine theta plus 4 cosine squared theta. No, correct to you all. This part of the integral, which I would probably at this point distribute to 1/2 just because it works nice and easy. This part of the integral can be done right now without doing any work. Agreed? Cosine squared, you have 2 options. You can do a trig identity, or you can call it cosine times cosine and do integration by parts repeatedly. Now remember doing integration by parts repeatedly and to get one to show back up. And So you got two options. One is integration by parts, twice, 3 times. I think twice. As soon as you got cosine to show back up, you could go back to place and do the integral with parts. How many of you would probably choose that option? The other option is to, and the reason I'm saying there is another option, in this class I picked, if that comes up on an AP test and you must do it, I do parts twice, sine squared or cosine squared, because that's what you're familiar with. If this came up in a college calculus class, it may come up on something where you are allowed to look up notes, or maybe on a homework assignment where you have to do it by hand, but you had to show some work. And there is a trig identity called the power reducing identity. Why I mention that is with Google, that's an easy question. You Google power reducing identity for cosine, and then you put that in, and what it does is it takes it down to cosine of 2 theta. It's like 1 plus cosine 2 theta or something. I would have to look it up. But you can put that in and divide and do the power reducing identity. So those are the two options. If you're like, okay, I'm going to stop there. I just wanted you to see where you would go with that if you were to need to in college calculus. Like I said in this class, I don't expect this to be something that you have to do by hand. But anyway, if I were going to approach it in this class, for some crazy reason it shows up on the AP exam and you have to, I would do parts twice.
Would you take the 4 out?
Yeah, probably. Mm-hmm. And then just do cosine squared. I would probably side note and do the integral of cosine times cosine. But UV cosine theta, UV cosine theta, dV cosine theta. Go from there. So it is. That's why I don't expect it to show up more than anything. And they don't typically expect you to know the power reducing identities. It's not it. Find the area bounded by the graph of this. It is nice to note what this graph looks like. I don't actually need to graph it, but it's nice to note what it looks like. It's one of the ones in that section where they had loops or no loops. You remember? This one has no loop. It does get a little more complicated if it has a loop. This one has no loop. How do I know it has no loop? Because I know the 2 and the 2 are the same, so this is a normal cardioid, normal heart-shaped graph. That being said, I don't need to graph it. I just need to be aware of that. If I want to find the area in this whole graph, what are my endpoints on my 0 to 2 pi? Everyone agree? I'm going to go all the way. What is my rule for area of a polar graph? 1/2 r squared d theta. You know that rule? That's just the area close to the polar graph. It's not too terrible. This integral by hand is the same as the last integral by hand, right? Got the sine squared again. So again, college Cal 2, will they make you do that integral by hand? Yeah, probably. In high school calculus BC, probably not. Any questions about that one? Don't want to see me do one that double just for practice the integration twice. And in fact, I'm going to go ahead and even pull out the other two. The left-hand part of that integral I can do right now, no problem. I hope. What's the antiderivative of 1? Yes, theta in this case. Antiderivative of sine. Okay, so I'm going to table that for a moment. And go work with the antiderivative of sine squared of theta. Again, if you're in a college calculus class and you get to look up notes, this is way too much work. Look up power reducing identity, it's faster that way. So if you wanted to memorize power reducing identity, you could. Antiderivative of sine is negative cosine of theta. Remember, I have the 2 in front. I'm kind of keeping it hanging out there, but just this integral portion, I get u times v. Right, that I'm gonna go over here. U is sine theta. V is negative cosine theta minus the integral v du, which is negative cosine squared theta. And I'm going to do integration by parts again. What's going to happen next time? So remember, this is the integral of sine squared of theta, right? This equals that. When I do the integral the second time, the sine squared is going to show back up. And so I can solve. I remember having to do this twice. Once. Station, right? I'm going to pull that negative out and make that a plus. So second v and u, let v equal cosine theta, and u equal cosine theta, v equal negative sine theta, v equal positive sine theta. Yes. See why AP doesn't make me do this very often. College calculus with different story. They don't care how bad you feel about it. So that's why you're taking this in high school. So we have, I now have the integral of sine squared theta, v theta, equals negative sine theta cosine theta plus that integral, which is u times v I did it right. That was from the original. Plus v times u, which is sine theta cosine theta. Good so far. Minus the integral of v APU, which is negative.
Because it originally was a negative cosine.
Yeah, negative sign.
And then it was a negative cosine. So you made it a positive cosine. Like that.
Then you make it a cosine to get negative sign.
That's negative.
Well, yes. Yeah, I think yes.
But then that's negative 2.
Yes.
Okay.
Yes. Yes. Okay. Wait, hold on.
That would be positive.
In previous, yeah, it was, see the negative cosine. No, right there.
So it's
We
positive.
took it out and made it more positive cosine.
Right.
So because it's a negative sign, it's negative inside that one. So then it got back.
Wait, but I thought that was positive to start with, and then you made it.
UV
Yeah.
minus.
I thought it was positive, and then you pulled the negative out.
It's positive. We have a problem.
I'm thinking that should be negative because I think you had the plus there, and then you did it in your head and just put the minus there, like you're supposed to. That's what you said you got. I mean, I think so.
Do what?
Use your math power.
You don't have to prove this.
No, I'm not. No, I'm just trying to answer the question. I'm not trying to prove anything. It's truly a question. I'm not trying to trick you. I'm really asking if it's positive or negative. Like I said, AP, you don't have to do this. Sometimes I like to show you college things. Yes, you are. But this should make you appreciate getting high school credit. Okay. It has to be positive, I believe.
Original integral was positive.
Which one?
The original integral was sine squared.
See, what you normally do is just subtract this. Problem. You see where my problem is having it? That's not going to
That's what I'm.
We're going to table this for today. I'll show you how to do it. I may be power reducing, but I'm making power reducing. I'll probably do it 7 hours and figure out my mistake. I think you were right. You think so? Well, I know the answer. Because it's I told him yes. Oh, I didn't do the whole thing. I just did sine squared. I was just trying to see if it would be our mistake, and I couldn't see it quick enough. Okay, next question.
Is the answer 2 pi?
I don't know. I didn't do the whole integral. I just did the sine squared. Okay. Area of one petal. Area of one petal. What does that mean that I need to know? Okay, maybe how many petals? There's 3, maybe 4. In particular, I need to know where to integrate from and to. Would you agree with that? That's the possible problem. Is find where to integrate from and to. Joseph, say that louder.
It's 2 zeros, or these are the pedal has to.
Okay, if I know where this touches the pole, right? If I know where it touches the origin, will I know where a pedal starts and stops?
Sure.
Yes. So, if that's something I can find, would that equal 0? So I really just want to know when sine of 3 theta equals to 0. Okay, and I'm going to start finding, well, when does sine equal 0?
The 0.
And I could go all day long if I wanted to, right? How many times do I need an answer?
2.
Just 2, because I need one touch and another touch, right? So, 0 and pi over 3. Now, quick shortcut trick. This will give me the area of one petal. How many petals are there? So, if I wanted the whole flower, multiply that area by 3. So, this is a good way to find the area enclosed in any flower. 3. You only double when it's even. When it's even, you double. When it's odd, it's 1/2 integral from 0 to pi over 3 to sine of 3 theta squared d theta. We are going to calculator that. Again, these turn out nasty. Why do they turn out nasty? Sine squared involved. So again, power reducing identity. I'll probably show you the power reducing identity just so we can have a way to do this by hand. Most likely they're either going to have you set it up and stop, or you will have a calculator.
1.047.
Okay, any questions about the setup on a one petal of that?
Worksheet talks about size.
Yes, you're right. Okay, that's the first. That's my. I'll get you one.